In this presentation, we have to talk about radiation from an oscillating electric dipole. We know that two equal and opposite charges separated by a fixed distance will constitute an electric dipole. If you want to measure the dipole moment P is equal to charge into distance of separation. This is our dipole moment. You should know the meaning of the term oscillating electric dipole. If the charge is sinusoidal, Q equal to Q0 e power minus I omega t, then dipole moment P equal to Q0 dl e power minus I omega t, which is equal to P0 e power minus I omega t. A dipole whose dipole moment varies sinusoidally is called an oscillating dipole. Now read out the statement. Two equal and opposite charges separated by a fixed distance will construct an electric dipole. A dipole whose dipole moment varies sinusoidally is called an oscillating dipole. Here the charge is sinusoidal, dipole moment is also sinusoidal. A dipole whose dipole moment varies sinusoidally is called an oscillating dipole. Therefore, this is an oscillating dipole. An oscillating dipole should radiate energy. Therefore, an oscillating dipole is known as current element. Take the differentiation of this dipole moment with respect to time, dp by dt, which is equal to dq by dl dq by dt into dl. Just we have differentiated this relation with respect to time. dp by dt equal to dq by dt into dl. We know that dq by dt is our current, dp by dt is our p dot. Therefore, we can write p dot equal to I into dl. Now read out this. An oscillating dipole should radiate energy. Therefore, an oscillating dipole is known as current element. P dot is equal to I into dl. To find out the energy radiated from the dipole, we have to mix few assumptions. The first one is the length of the dipole is small, much smaller than the wavelength of the emitted radiation. See, the distance between plus q and minus q is our length. dl is far lesser than lambda. The length of the dipole is much smaller than the wavelength of radiation coming out of the source. See here, along the z direction, the dipole moment is oriented. The unit vector is also present along the direction of z. If you consider a point P, an observer is present at this point P. For the observer, the radiation coming out of different sources are reaching that point at the same instant of time. Now read out the second statement. The radiation from different source points of the dipole should reach point P at the same instant, and therefore there is no phase difference between the waves reaching point P. That is another condition. If you consider the unit vector n cap is equal to nr cos theta plus n theta cos 90 plus theta. See here, the point P is at a distance r from the origin. which makes an angle theta with the normal. So the unit vector n cap is equal to nr cos theta plus n theta cos 90 plus theta, because the angle between nr and n theta is 90 degree. You know that cos 90 plus theta is minus sin theta. Therefore n cap equal to n suffix r cos theta minus n suffix theta into sin theta. Now we have to find out the terms vector and scalar potentials. Vector potential A is given by the formula A equal to mu naught divided by 4 pi integral j dv dash divided by r. Here the meaning of the square bracket is which is subject for accordation. But j dv dash inside the integral equal to I into dl. We already have the value dipole moment P equal to q into dl, P dot equal to dq by dt into dl, which is equal to I into dl. So instead of j dv, we may put P dot. Actually, integral j dv dash is equal to I into dl. I into dl is replaced by our P dot. So the vector potential A is mu naught divided by 4 pi r P dot inside the square bracket. This is the value of vector potential. The vector potential is depending on r. It varies as r power minus 1, and the direction of the vector potential is along the direction of P dot. That means along the direction of z axis. Now read out the statement. Vector potential depends on r and varies as r power minus 1. Here r is present in the denominator. The direction of A, that is vector potential, is along P dot. Here P dot is along the z axis. If n cap is a unit vector, then A vector potential is equal to mu naught divided by 4 pi r P dot into n suffix r cos theta minus n suffix theta sin theta. But A is also represented in terms of unit vector. We may write AR NR plus A theta N theta plus A pi N pi, which is equal to mu naught divided by 4 pi r P dot inside the square bracket multiplied by NR cos theta minus N theta sin theta. Now we have to compare the coefficients of NR and N theta. From this, AR, which is equal to mu naught divided by 4 pi r P naught inside the square bracket into cos theta. This is value of AR, the A suffix r. In the same manner, A suffix theta, which is equal to mu naught divided by 4 pi r P dot sin theta with a negative sign. This is the value of A theta, and the value of A pi, equal to 0. That's all about the vector potential. Next we will go to the scalar potential pi. To get the scalar potential, we should start our journey from the Lorentz condition. The Lorentz condition for free space is div A plus mu naught epsilon naught dou pi by dou t equal to 0. Suppose an electromagnetic wave is propagating through vacuum, its velocity c equal to 1 divided by mu naught epsilon naught inside the root. So in the above relation, instead of mu naught epsilon naught, we may write 1 by c square. So the above relation is modified as div A plus 1 by c square dou pi by dou t equal to 0. Then dou pi by dou t, which is equal to minus c square to div A. Div A in spherical polar coordinates is 1 by r square dou by dou r of r square ar plus 1 divided by r sin theta into a theta. Here we have to put dou by dou theta. Dou by dou theta sin theta into a theta plus 1 divided by r sin theta dou a pi divided by dou pi. This is the div A value in spherical polar coordinates. Del dot A equal to 1 by r square dou by dou r square into ar plus 1 divided by r sin theta dou by dou theta into sin theta a theta plus 1 divided by r sin theta dou a pi divided by dou pi. But in the present case, the value of a pi equal to 0. Here a pi equal to 0. Therefore the last term is vanished. We have to use only these two terms. Instead of div A, we have to use only these two terms. This is the new equation we have arrived. In this equation, we have to substitute the values of AR and A theta. So dou pi by dou t, which is equal to minus c square into 1 by r square dou by dou r of r square into ar. Ar value is 1 by 4 pi epsilon 1 by 4 pi r, then p dot into cos theta. This is the value of ar. So r square into ar. Here numerator carries mu naught. Mu naught divided by 4 pi r. P dot cos theta is the value of ar. Then minus 1 divided by r sin theta dou by dou theta of sin theta mu naught divided by 4 pi r p dot into sin theta. Here the value of a theta is minus mu naught divided by 4 pi r p dot sin theta. We have taken out the negative sign also commonly. This is equal to minus c square divided by 4 pi multiplied by mu naught. So we have taken out mu naught divided by 4 pi outside. 1 by r square dou by dou r of r square p dot by r into cos theta, then minus 1 by r sin theta dou by dou theta of sin theta is sin square theta p dot by r. Just we have taken out mu naught divided by 4 pi outside. Now you have to simplify this. Now consider the first part. This is equal to minus mu naught c square divided by 4 pi 1 by r square p dot of cos theta plus 1 by r dou by dou r of p dot to cos theta. See, this is the first term. We are making a differentiation with respect to r. So r square by r is r. Dou of r by dou r is 1. So 1 by r square p dot cos theta. And then dou by dou r of this p dot. R square cancelled out. 1 by r dou by dou r of this p dot into cos theta. P dot is also a function of r. Now come to the second term. See, 1 by r sin theta 2 sin theta cos theta p dot by r. This is equal to minus mu naught c square divided by 4 pi 1 by r square p dot cos theta plus 1 by r dou by dou r of p dot inside the square bracket into cos theta. Here minus 2 cos theta by r square p dot inside the square bracket. Now you have to combine these two terms. This is equal to minus mu naught c square divided by 4 pi. Write on this term 1 by r dou by dou r of p dot inside the square bracket in cos theta. 1 by r square p dot cos theta minus 2 times cos theta p dot divided by r square. It is minus cos theta p dot divided by r square. 1 by r square p dot cos theta minus 2 times 1 by r square cos theta p dot. That is equal to minus of cos theta p dot by r square. This is the value of dou pi by dou t. Now we have to simplify further. In the dou pi by dou t, we have to find the value of dou by dou r of p dot inside the square bracket. Now that p dot inside the square bracket equal to p dot of t minus r by c. This is the value of p dot inside the square bracket. Then dou by dou r of p dot inside the square bracket, which is equal to dou p dot t minus r by c, dou of t minus r by c into dou of t minus r by c divided by dou r. See here, dou of t minus r by c, dou of t minus r by c cancelled out. We can get dou by dou r of p dot t minus r by c. P single dot inside the square bracket equal to P dot T minus R by C. We need the value of dou by dou R of P single dot inside the square bracket. That is, this is equal to actually dou by dou R of P single dot T minus R by C. Dou by dou R of P single dot T minus R by C. This is the meaning for dou by dou R of P single dot. Instead of this term, that is, instead of the total, we have written dou P dot of T minus R by C divided by dou of T minus R by C into dou of T minus R by C divided by dou R. These two terms are cancelled out. We can get dou P dot of T minus R by C by dou R. If you assume this T minus R by C is T dash, then dou P dot divided by dou T is P double dot. So this is P double dot of T minus R by C. Then dou by dou R of T minus R by C is minus 1 by C. This is actually P double dot inside the square bracket, which is multiplied by minus 1 by C. So instead of this term dou by dou R of P single dot inside the square bracket, we have to use minus 1 by C P double dot inside the square bracket. Now dou pi by dou T becomes dou pi by dou T, which is equal to minus mu naught C square divided by 4 pi multiplied by 1 by R dou by dou R of P dot cos theta. So instead of dou by dou R, we have to put our value. Instead of this dou by dou R P dot, we have to use minus 1 by C. So minus 1 by RC P double dot inside the square bracket into cos theta. Instead of dou by dou R P single dot inside the square bracket, we have to use minus 1 by C P double dot inside the square bracket. So this is changed as minus 1 by RC P double dot inside the square bracket multiplied by cos theta minus of cos theta P single dot divided by R square. This is value of dou pi by dou T. Now we have to modify this further. See, allow the negative sign to operate on all. Mu naught C square divided by 4 pi cos theta P single dot divided by R square plus 1 by RC P double dot inside the square bracket into cos theta. Then we may write this one as P single dot into cos theta for our convenience. You know that C equal to 1 divided by mu naught epsilon naught inside root. C square is 1 divided by mu naught epsilon naught. So instead of this C square, we may put 1 by mu naught epsilon naught. Then dou pi by dou T equal to 1 divided by 4 pi epsilon. Instead of this C square, we can write 1 by mu naught epsilon naught, mu naught get cancelled. So 1 divided by 4 pi epsilon naught into P single dot cos theta by R square plus 1 by RC P double dot cos theta. We need the value of pi alone. Therefore, We change this one as pi, which is equal to 1 divided by 4 pi epsilon naught p divided by r square cos theta. This p dot is dou by dou t of concentration of p. Here also dou by dou t is present. That dou by dou t is removed out. Plus 1 by rc p single dot of cos theta. See here, this p double dot is dou by dou t of p single dot. Here p dot is dou by dou t of p, dou by dou t of pi. We may cancel dou by dou t entirely. So pi equal to 1 divided by 4 pi epsilon naught p inside the square bracket divided by r square cos theta plus 1 by rc p single dot, because dou by dou t of p single dot is p double dot. We have cancelled dou by dou t on both sides multiplied by cos theta. This is the value of scalar potential